Hi everyone, I am Durga Devi, Assistant Professor from SNS College of Pharmacy and Health Sciences. In this video, I am going to talk about the various principles involved in the estimation of fluorescence produced by fluorescent compounds. We have seen about the electronic states and the principle involved in fluorimeter in the previous video, and on continuation to that, today we are going to see about the relaxation processes, that is internal conversion, external conversion, and the overall Jablonski diagram. And the first one is internal conversion. So in the internal conversion takes place only this internal conversion happens because the changes are happening within the molecule. The internal conversions happens because the changes are happening within the molecule. So the internal conversion happens within the molecule, that is intramolecular interaction. Here the electrons will move from the higher energy state to a lower energy state. So the changes are happening within the singlet excited states. Here the energy present in the molecule are released in the form of vibrational relaxation and some other non-radiative relaxation processes. Especially the energy is lost mainly in the form of heat. Then next to internal conversion is external conversion. So external conversion means the changes are happening in between the molecules. That is one of the molecule present in our fluorescence sample will react with the solvent molecule or some other substances which were used for preparing the solutions, and because of that interaction some amount of energy will be lost, and that is called as external conversion, and this may be lost in the form of collision or heat. Then next to this external conversion we have intersystem crossing. This intersystem crossing is a forbidden one. This happens when the environment that where the reaction is happening is having low temperature, or maybe it may have the presence of oxygen, where the electrons will move from singlet excited state, that is from S1 to triplet excited state, and we can say this as a forbidden transition because the singlet excited state will have electrons unpaired, but they will be having opposite spin, but whereas the triplet excited states will have unpaired electrons, but those electrons will have same spin. So the spin differences between these two levels are very different. So it is really forbidden to transfer the electrons from singlet excited state to triplet excited state, but it is happening because of some environmental conditions, and that is called as intersystem crossing. And because of this intersystem crossing we may have a phosphorescence effect that can be explained with the help of this diagram. It is called as Jablonski diagram. Here the S0 indicates the singlet ground state, and the S1 indicates the lower energy level of singlet excited state, and S2 is the higher energy level of singlet excited state, and T1 is the triplet state. Here the blue line indicates the absorption, the light radiation that is absorbed by the molecules, that is the electrons present in our molecule. As they absorb the light radiation, they move from singlet ground state to singlet excited state, where it takes the time duration of 10 to the power of minus 15 seconds, that is femtoseconds. Then after going to S2, that is the higher energy level of singlet excited state, they move to the lower energy state by emitting some energy. that is a non-radiative process, and that is called vibrational relaxation, which actually happens because there is a vibrational energy lost from the molecules, and that may take about 10 to the power of minus 12 to 10 to the power of minus 10 seconds. Then after that some amount of energy is lost in the form of fluorescence when the electrons move from singlet excited state to singlet ground state. That may take about 10 to the power of minus 10 seconds to 10 to the power of minus 7 seconds.